Hello everyone, welcome to Smart Sessions by Smart Interviews. In today's video, we are going to look at this problem called removed nth node from the end of the list. I recommend you pause the video here, go through the problem statement and come up with an approach. Now, how do we solve this problem? If you look at the example that is given here, you are given a linked list with 6 nodes and you are given the n value as 2. So you have to delete the second node from the end, which is this node 5 with a value of 9. Now how do we do it? To delete this node, I simply have to link the next pointer of 4 to 6. The fourth node's next pointer should be linked to the sixth node. Now how do I do that? First, to link the fourth node's next pointer to 6, I need a pointer which is pointing to the fourth node. So I have to iterate and go to the fourth node. To go to the fourth node, I can simply iterate for 4 times. So what will I be doing here? I will first find the length of the linked list. Let's say we have a function called find length, which will give me the length of the linked list. We'll send the head of the linked list to this node and I will store it in a variable called length. Next, once we find the length of the linked list, I already have the node which I am supposed to delete. So if I just subtract these two, if I do length minus n, I'll get the node at which I have to stop, which is 6 minus 2, that will give me 4. Now I simply have to go to the fourth node and delete the fifth node by pointing fourth nodes next to 6. So for that, all I have to do is I'll simply take variable, let's say p1, which will point to the node I'm currently at. So I have to declare it as node. Okay, and I will also take a variable called, let's say, c, which will keep track of which node I am at. Initially, c will be 1 because I am at head. Now all I have to do is I should iterate p1 till c becomes 4. So I'll simply do while c is less than length minus n. I'll simply do my p1 is equals to p1 dot next. Okay, so what is exactly happening here? I have my length minus n as 4. So initially c will be equals to 1 and I have a p1 pointer. Now p1 moves forward and once I move p1 forward, I should also increase my count. So I can write c++ over here, which will increase my count. So now c will become 2. Then again it will check if c is less than length minus n, which is true. So again it will move p1 forward and it will increase c. Then again it will check, it will see that it is less than length minus n. So again it will increase p1 and it will increase count. Now it will see that c is not less than length minus n. So it will not go into the while loop and it will not move forward. Now all I have to do is link p1 dot next to p1 dot next dot next. That's it. This is what I'm supposed to do. Okay, now this is the basic idea behind this logic. Now do you think this code is going to work? There is a small edge case where this is not going to work. What if you are asked to delete the head node? Let's say your n is equals to 6. What will happen when your n is equals to 6? You are asked to delete the sixth node. So your n minus length minus n will be 6 minus 6, which is equals to 0. So c will be less than length minus 6 and your p1 will be currently at head itself. Now it is not going to move your p1 forward and it is going to delete the second node, not the first node. because you will directly do p1.next is equals to p1.next.next. So how do we fix it? This is an edge case, so we fix it like edge case. So before we do all this, we'll simply check if my length is equals to n. If length is equals to n, I have to delete the head node. So to delete the head node, I'll simply return my head.next, which will return this as my head, the second node as my head, and it will look like the head node is deleted. So if length is equals to n, I'll simply return head.next. Otherwise, here I'll return head. That's it. This is the basic logic behind deleting the nth node from the end. Let's code it up and see if it will work. Okay, let's code it up. So what is the first thing that we need? We need the length of the linked list. So let's write the function which will give us the length of the linked list. So I'll have find length, which will take the head of the linked list. So how do we find the length? It's very simple. I'll take a variable which will hold the length of the linked list. Initially it is going to be 0, and I'll iterate my head to the end. So I'll do while head is not equals to null. I will do head is equals to head dot next, and I should also do length plus plus to increase the length, and I'll simply return the length. Okay, now let's call this function in our main function to get the length of the given linked list. So I'll declare another variable called length, and I'll use the find length function to get the length of the given linked list. Then what should we do next? We have to check if the given node is the head node. So if length equals to head, I'll simply return head dot next like we discussed, and then I will declare the p1 pointer and the c variable. Here, instead of taking the variable name as p1, you can simply move the head forward as well and link head.next to head.next.next, but then you will have to keep the original head so that you can return the original head later. Instead of that, I'm taking p1 and moving p1 forward. So p1 will be initially equals to head, and I need another variable c which is equals to 1. Then I'll check if c is less than length minus n. If it is less than length minus n, I'll move my p1 forward. So p1 will be equals to p1 dot next. In addition to this, I should also increase my c. Then at the end, I will delete the p1 dot next by doing p1 dot next equals to p1 dot next dot next, and finally I'll return head. Okay, looks like I made a typo here. My length spelling is wrong. Okay, it should be n, not head, equals to our list. Now, so it got accepted with the sample test cases. Let's submit and see if it will get accepted. And it's done. I hope you liked this video. See you in the next video. Thank you for watching. Please like, share and subscribe for more such content.